Hey, it's Trip here from the 87th. This video is about course intercepts in BMS 4.33. Information current as of update 1. Course intercepts means using the HSI, the horizontal situation indicator, to intercept either radials outbound from a station or courses inbound to the station. That station could be either a nav fix, in other words a steer point, and we're using that because they have the mode selector in nav. Or you could be using the same procedure to intercept a TACAN radial outbound or a course inbound to that TACAN station with the selector in TACAN. Right now we're using a steer point fix, which we've just passed. We're only 8 miles and we're going outbound because the head of the bearing pointer always points to the, in this case, the steer point, so it's behind us, and DME is going to be getting bigger. The tail of the bearing pointer is always connected to the head of the bearing pointer, as you can see there. So if this is the head, then this is the tail. And the tail of the bearing pointer always tells us what radial we're on. Well, that's where we are. We're on this radial. But I want to intercept the 170 degree radial outbound, the 170 degree radial outbound. So what heading do I have to turn to in order to accomplish that? So there's a memory aid for it. It's called trout, just like the fish, T-R-O-U-T. The OUT stands for outbound, so this is a procedure that we need to use when we're talking about radials outbound. There'll be another procedure when we talk about course intercepts inbound. But for now, we're going to use the trout method. The T stands for the tail of the bearing pointer, so we locate the tail of the bearing pointer, and then we go in the shorter direction to the radial that we want to intercept. I think I said 170, so we go from the tail to the right over to 170, and we keep going in that same direction to the right in this case, another 45 degrees. Well, 45 degrees might be a little too much, so I'm just going to eyeball it here. We're going to go from 170, from the tail of the bearing pointer to 170 plus another 35, call it 205. Let's just turn to 205. That's a little short of 45, but it's just a wag, really. It doesn't have to be 45 degrees. It can be more or less depending on how far from the station you are. So the idea here is I want to turn to a heading that will place the tail of the bearing pointer in a position where it can rise up to 170. Because remember, the tail of the bearing pointer, when your wing's level, it always rises in the instrument case. It always goes up. If the head of the bearing pointer always falls, as it does, then that means the tail has to rise. So if we hold this heading, eventually the tail of the bearing pointer will come up to 170, and then we can complete our intercept by turning back to the left of 170. We'll have the tail on the 170 heading here, and we'll be going outbound on the 170. Let me speed up the machine here a little bit, see if we can get that tail to rise a little quicker. There she goes. The head always falls, the tail always rises. Now just before it gets there, we turn back to 170, and then we'll be flying outbound on the 170 degree radial. Now that could be a radial on a standard instrument departure that you're flying, or an approach plate missed approach procedure that you need to intercept a radial outbound. So this is the technique for that. It's an easy way without having to go down here and spin the course arrow to 170. Now you could do that. There's nothing against that, I'm saying, but if this was, for instance, our inbound ILS course here, 240 or 236 in this case, and we had to make a missed approach, and the missed approach instructions say, climb straight ahead to 4 DME, make a left turn, intercept a 170 degree radial outbound. I don't have time to be down here, spinning this knob here, playing Wheel of Fortune. And when I can just simply look for the tail of the bearing pointer, the radial I want to intercept, go another 30-40 degrees in that same direction, roll out and wait for the tail to come up to 170, and then turn back to 170. I mean, that to me is a lot easier than taking my hand off the throttle or stick to rotate this knob down here. Alright, so it has its uses. It's a basic skill you probably really want to master if you're going to be a good instrument pilot. Alright, so that's a radial outbound procedure. Let's turn inbound here and give ourselves a course inbound intercept. And I'm going to speed up the machine here. Hopefully the autopilot can handle this. If you've seen some of my videos, you know I hate flying down here on these instruments, hand flying. Alright, I'm going to have us going almost to the station here. I'm going to roll out, and we're flying this heading right here, and we want to navigate to the initial approach fix for some instrument approach. And that initial approach fix, it's on the, say, the 190 degree radial from a TACAN station. Well, when you hear radial inbound, in other words, the approach shows that we need to intercept the 190 degree radial inbound. When you hear radial inbound, you just change that to course inbound. So you take the reciprocal. So if it says 190 degree radial, if the fix is on the 190 degree radial from the station, then you have to take the reciprocal of that, which would be 010 degree course inbound. So the 190 degree radial inbound is the 010 degree course inbound. And so now we have another memory aid for intercepting courses inbound, and that is chin, C-H-I-N, just like the chin on your face. So the I-N means this is the little procedure we're going to use when we're talking about courses inbound, I-N. And so now the C stands for the course that we want to intercept. So in this case it's 010, it's right here. And then we go in the shorter direction to the head of the bearing pointer. That's what the H stands for. And then we go in that same direction, always go in that same direction. So in this case it's the left, can just continue left to a heading, 30 or so degrees in that same direction. So it looks like we've rolled out on it already. We're already on the proper heading here, so that's pretty cool. Let's take the machine off of freeze, and I'm going to speed it up here, and we've put the head of the bearing pointer in a position where it can fall. It's going to eventually fall, as it always will, and when it approaches 010, then that's when we're going to start our turn to 010 and complete the intercept. So I'll give it another little bit of time here. Alright, that's pretty good right there. So I'm going to turn to 010. And now we're at 24 DME. Let's say that initial approach fix was on the 190 degree radial for 15 miles. Well, we're on the 190 degree radial inbound to that fix. When we get to 15 miles, we'll be there and we can start the approach. So that's how that works. So you have trout plus 45 and chin plus 30. Now the plus doesn't mean that you always add. The plus doesn't mean that you go from, say, the course that you want to the head of the bearing pointer and then add 30. It doesn't mean you come back in this direction 30. It just means you go in the same direction 30. Same thing for trout plus 45. It just means you go another 45 degrees in the same direction and then roll out on that heading. So that either puts the tail of the bearing pointer in a position to rise, or for inbounds it puts the head of the bearing pointer in a position to fall to the selected course or that you want. Now one last thing before I go is the closer you are to the station, the more sensitive the bearing pointer gets, because all these 360 degree radials, they converge right here at the station, or in this case the fix. So the head of the bearing pointer starts moving real quickly as you get close to the station. So you may not even need a 30 degree cut or a 45 degree cut. You may only need like 10 or 15 degrees of cut, depending on whether you're going inbound or outbound from the station. Alright, so one more explanation here and then I'll cut it off. When you're 60 miles from the station, each one of these radials is the distance between two of them, put it that way. Let's say the distance between the 150 radial and the 149 degree radial, that's 1 degree difference. When you're 60 miles from the station, that 1 degree difference equates to 1 mile of ground distance. When you're 30 miles from the station, then 1 degree difference in radials is a half a mile, and so forth. So you can see that the further you are away from the station, the more distance there is between the radials. So that's why you have to make a bigger cut. So when you're going outbound, generally you make a bigger cut. That's why it's trout plus 45 as opposed to 30. When you're going inbound, they're assuming that you're getting closer to the station. You don't need as big a cut because the radials are the distance between the radials is getting smaller and smaller as they converge toward this steer point here. So you don't need more than 30 degrees. So as I said, it's just a rule of thumb. You don't have to be exactly 30 or 45. You just have to use a little discretion. Look at see how far from the station you are. All right, I think that's what I want to explain about course intercepts. I hope it helps. Trip out.